In this video, we're going to look at a concept that's called nominal and effective interest rates. We're going to start by defining what is nominal, and then we're going to convert nominal rates into effective rates, because effective rates are the rates that you can use in enduring economy problems. And then the special case of continuous compounding and converting that interest rate into an effective rate. So looking at nominal and effective rates, really what the difference is nominal is a rate that doesn't include compounding, and effective is a rate that does include compounding. So because of enduring economy, the convention is that we use compounded interest rates. We want everything to be converted to effective. So if we're given a nominal value, we need to convert it. Now, that'll happen once in a while. These are two examples, and it happens actually in commercial kinds of bank rates, things like that. They'll be stated almost always in nominal. So in this case, the Chase credit card is 22.99% APR compounded, and APR stands for annual percentage rate, and it's compounded monthly. So what that tells you, this word compounded, tells you that that is a nominal rate. That means it doesn't have compounding in that value. And the same for the 0.9% for the savings rate at Wells Fargo is compounded daily. So what that means is the nominals, you can't use it in any kind of enduring economy calculation. It needs to be converted. And the way we convert it is by using this equation. The effective rate, an annual effective rate, is 1 plus r over m to the m power minus 1. In addition, the interest rate per compounding period, where m is the compounding period, is r over m. So we're going to look at this, how to actually find out the annual effective and the effective per compounding period. So we'll look at this. First thing you need to know is how to sort of tease out the values, this R and this M value. For the Chase credit card, the R value, the nominal interest rate, is 22.99%. M is 12 because it says it's compounded monthly. For the savings account, it's 0.9% is R, and the compounding is 365 because it's daily. So that's how you get those values in order to plug into those equations. So let's look at this example where we have a credit card at 22.99% compounded monthly. We're going to convert that into an annual rate using this equation. So R is 22.99 and M is 12. So we go ahead and put those values in there. Now, when I do this calculation, I either include the percentage sign or I'll put it at 0.2299. But for me, when I'm doing these calculations, those are interchangeable. You can do either one of those. So for the actual calculations, you have to do 0.2299 divided by 12 plus 1 to the 12th power minus 1. And that gives you 25.6. So you can see that when we include compounding, it's quite a bit more than the uncompounded value. The 22 almost 23% becomes 25.5%. Now, the effective rate per month then, because this value is compounded monthly, the rate is R over M, so it's 1.92% per month, almost 2% per month. So that's how you get that value. Now let's look at the other one. We're going to use the same equation for the Wells Fargo savings account. So we're going to take 0.9% divided by 365 to the 365th power. So what this is telling us is we're going to take each monthly rate and each daily rate and compound it 365 times. That's really what we're doing. That gives us 0.9%, 0.904%. So before it was 0.9, now it's 0.904. And then, oh shoot, that should say what's the interest rate per day instead of per month, because that's what we're that's how the compounding works. So we do R over M is I is equal to R over M. So in this case, the interest rate per day is 0.9 divided by 365, which is 0.0025% per day. Now, there is a special case that sometimes things are written as compounded continuously. That means that it's compounded every moment. And so in order to get that calculation, to figure that out, we take the limit, and it ends up the effective rate is e to the r minus 1. And so in this case, taking 12% e to the 0.12 minus 1 gives us 12.7%. So again, it's a little bit more, but it's not a huge amount more. So there is a limit to this compounding. So the things we've covered in this video are defining what nominal rate is, converting annual nominal to effective interest rate, and we also found the interest rate per month. So this is the three equations that we are using in this video.